Afternoon, class. It's Sir Capistrano again, and welcome back to Camp 21. For today we'll actually continue on our discussions of carbonyl compounds, we named aldehydes and ketones. So as we have discussed last video, we talk about carbonyl compounds and their general structures. So we identified aldehydes and ketones as members of carbonyl group, wherein in the last video we actually focus our discussions on nomenclatures of carbonyl compounds, wherein we determined the IUPAC name and the um, common names of ketones and aldehydes, wherein we showed different examples and different ways on how we can name for ketones and aldehydes. And for today, we'll be moving on into the next part of discussions, just like any other of our videos, wherein we will be talking about the physical properties of carbonyl compounds, and also lastly, we'll be talking about the reactions of carbonyl compound. So for carbonyl compound, there are actually five main reactions of carbonyl compounds, which we will be discussing later on. But first, let's talk about the physical properties of carbonyl compounds. So, by carbonyl compounds, as you may have remembered, carbonyl compounds are organic compounds bearing this carbonyl group, wherein we have uh, carbon to oxygen double bond, and that is what we call the carbonyl group. So, for the carbonyl group, they are extremely polar, especially the aldehydes. Bakit sila highly polar? This is uh, due to the presence of what we call carbonyl group. So this polarity is actually due to the presence of that double bond of carbon and oxygen, and bearing double bond, we have here an electron-rich region, which makes this portion of the carbonyl group as our negative side, or the negative side of our molecule, and the R group and the carbon itself acts as the positive part of our compound, making this highly polar. So bakit ko especially sinabi yung sa aldehydes kanina? As you may have remembered, aldehydes have R group on one side and it has hydrogen on the other side. Bakit mas magiging mas magiging polar? Because the R group and the carbonyl carbon will act as the positive side of our carbonyl group, and the oxygen will serve as the negative side, making this highly polar. So this high polarity is due to the carbonyl group itself. Carbon to carbon double bond, to the bonds on those double bond and the oxygen itself. And uh, so making this one of the physical property of carbonyl groups we have here, they are highly polar. So another physical property that may have been unique with with our carbonyl groups is that it's intermolecular forces that happens with our carbonyl groups are actually somewhere in between our other organic compounds that we already discussed in this class. So by other organic compounds, uh, aldehydes and ketones are actually less have less intermolecular forces of attraction than our alcohol. And on the same side, alcohol and phenols yan. Pero mas mataas naman yung kanilang intermolecular forces in comparison with alkanes and ethers. So why is that? As you may have remembered, the most prominent intermolecular forces of attraction between ether molecules and alkane molecules are our van der Waals forces of attraction. And as for alcohol, we have here hydrogen bond. So when we are talking about aldehyde to aldehyde interaction, wala tayong hydrogen bonding. So this is due to the polarity. Okay? So if alkanes and ethers are dependent on van der Waals forces of attraction, aldehydes and ketones are actually dependent on the polarity. Since we said that aldehydes or and ketones, or what we call carbonyl groups, have high polarity. Although aldehydes and ketones, so banggitin na natin, they are not capable of hydrogen bonding within themselves. Pero it can form H bond with water. So due to that possibility of hydrogen bonding with water, carbonyl group or yung ating carbonyl compounds, uh, carbonyl compounds are actually highly soluble in water. So those are the physical properties of our carbonyl compounds. First things first, they are highly polar. That is due to the oxygen and carbon double bond that is present on our carbonyl group. Uh, Intermolecular forces of attraction are actually lower in aldehydes and ketones, considering molecules with almost similar molecular weight in comparison with alcohol, but it is actually have higher intermolecular forces of attraction than ethers and alkanes. So, dahil doon yun sa polarity natin. They are not, carbonyl compounds are not capable of hydrogen bonding with themselves, and also they are highly soluble in water due to the possibility of hydrogen bonding with water. So those are the physical properties or the main physical properties of carbonyl compounds. Okay, so in that, we will be moving into the reactions of carbonyl compounds, wherein we will be talking about oxidation, heliform reaction, and nucleophilic addition. So first things first, let's talk about the oxidation of aldehydes. So baka magtataka kayo, bakit yung aldehydes lang yung merong oxidation? So by oxidation, familiar naman na tayo dito. Yung O dyan ay yun yung tinatawag nating oxidizing agent. So we have there our aldehyde. Okay? And as you may see here, when aldehydes undergo oxidation, we will have here our carboxylic acid. So, some of you may be asking, oh, bakit sir ganun? Bakit yung aldehydes lang yung nag-undergo ng ating tinatawag na oxidation? It is because aldehydes are much easier to oxidize than ketones because the reaction involves the cleavage of our carbonyl carbon hydrogen bond. So, ano ba yung sinasabi nating carbonyl carbon? We have here our carbonyl carbon and this hydrogen bond. This is much easier to break than yung tinatawag nating carbon-to-carbon double bond. So, meaning to say, aldehydes are more sufficient or kumbaga more, it is easier pala, it is much easier, not more easier, it is much easier to break that bond, this bond, uh, kesa dun sa ating uh, carbonyl to carbon bond sa mga ketones natin. Pero when we talk about ketones, ketones are relatively resistant to oxidation, just like our acetone. That is one of the most common ketones na pwede nating makita. And to have an oxidation or to perform oxidation sa mga ano natin sa mga ketones natin, meron lang mga special na ketones that may undergo what we call somehow parang oxidation but it is actually the formation of haloform reaction of methyl ketones. So by methyl ketones, uh, you must remember that ketones have two R groups on each side of the carbonyl compound. So we have here the first R group and the second R group. And for halo formation reaction to occur, it must one of the chain or one of the R groups of the ketone must be a methyl. So, makikita nyo dyan, CH3 yung nasa kanan. So, hindi mag-o-occur yung ating haloform reaction kapag wala yung ating methyl sa dulo. So, in that, due to the presence of halogen and our base there, our hydroxide, we may have the substitution of our halogen dun sa ating mga hydrogen. That's why we have here the CX3. That X is actually our halogens. And for the second step of the reaction, if we have uh, the second mole of our hydroxide or yung ating hydroxyl group, we will have here this compound wherein we call this our carboxylate anion. Okay, bakit saan ion? Kasi we have there our negative charge. So as you may see here, kapag nagdagdag na tayo dito ng ng acids natin, by acids we have there our H plus, pwede na tayo magkaroon ng ating oxidation wherein nadagdagan na yung number ng ating oxygen dun sa ating metal ketone. Then, kung nagkataka kayo kung saan galing yung haloform, this one is what we call the haloform. By haloform, we have there our halogen, uh, that is connected to our formaldehyde or form. Kaya siya tinawag na form kasi metal pa lang. Metal lang siya. So one of the haloform formation na pwede natin gamitin, pwede tayong gumamit ng NOx. By NOx, we can use sodium, this one. This is one of the reagents that we can use. So we have here our uh, halogen, and this is our extra oxygen. So that is our halo reaction of metal ketones. So baka iniisip niyo, sir, sa metal ketones lang ba nag-o-occur yung ating haloform reaction? Actually, hindi naman. It can happen with our so that it can happen with our acetaldehyde. So by acetaldehyde, as you may have remembered, aldehyde siya, pero ang itsura niya, we have here our carboxyl group. Then we have here a methyl. Then we have here our hydrogen. So we have here our acetaldehyde, wherein if this undergoes what we call the haloform reaction, yung substrate natin, siya ay magiging ganito ang itsura. Wherein, ano nga ba maging itsura? Wherein we will have here this compound, wherein we have here this hydrogen, we have here this somehow a carboxylate ion, and an ion, and we will have there our CH3, CHX3. Bali, ano yan, class, two-step yung reaction na yan, ginawa ko na lang one step para makita nyo agad yung product. Okay? Pwede rin naman mangyari ang haloform class sa ating mga alcohols. So by alcohols, if we have tertiary alcohols, it can also happen wherein our alcohol is located at the second carbon atom, wherein halimbawa, ito yung ating alpha carbon. Then we have here our hydroxyl. You must have here a CH3, and you have here a hydrogen and an R group dun sa kabilang side. So, ito yung mag-undergo ng tinatawag nating uh, ionization, kasi yan yung makakapagtan ng ating oxygen, at dyan manggagaling yung haloform. Okay? So, Basically, haloform reaction can happen with metal ketones, acetaldehyde, and our two propanol, two propanol, and the like. Alright? So our next reaction is the reduction to alcohol. So by reduction to alcohols, this is just read just like any other organic compound. If we have oxidation, we may also have reduction. But hindi yun totoo. Minsan merong mga organic compounds na hindi natin pwedeng i-reduce. So in this scenario, we actually have here the general reaction mechanisms of our reduction to alcohols of our aldehydes and ketones. So ito yung ating aldehyde and this is our ketone. So as you may see here, mayroon tayong magkaibang product sa ating aldehydes and ketones. Wherein for aldehydes, the resulting product should be a primary alcohol. And as you may see here, for the ketone, our product is actually a secondary alcohol. Okay? So, saan napunta yung ating reducing agent? Andito siya sa baba. So, some of the reducing agent na pwede natin gamitin dyan ay yung mga reduction din, pang-reduction din na ginagamit natin. Last time, we can use hydrogen gas in presence of nickel, platinum, or palladium. We can also use our lithium, o yung ating sodium bromide, then in the presence of acid. So, basically, ang pinakamadaling tandaan ay yung ating hydrogen gas in presence of nickel. Okay? So, one of the reducing agent na pwede natin gamitin, sulat ko na dito, is our hydrogen na catalyze ng ating nickel or platinum or palladium. Okay? So, those are some, ayan ang isa sa mga pwede nating gamiting reducing agent. Okay? So, tandaan yan ha. Pag aldehyde, nag-reduce, we have primary alcohol. Pag aldehyde, inoxidize, magiging carboxylic acid. Pag ketone, ni-reduce natin, we will have there our secondary alcohol. Okay? So, our next reaction is what we call, may na-miss na ako. Hindi ko alam kung bakit ko siya na-miss. But in any case, dagdag ko na rin dito. Yung pang-apat dapat, hindi ko na ilagay. So, we have there our reduction to methylene group. Kung naiisip nyo kung ano yung naiisip ko. By methylene group, this just means that we are just converting our uh, our aldehyde and ketones into alkanes. So, by alkanes, ano nangyayari dyan? So, kung meron kang aldehyde, gagamit ka ng reducing agent, pwede kang magkaroon ng ganitong compound wherein we just remove our carbonyl group and replaced it with our hydrogen. So, pwede rin dito ang mangyari kung halimbawa meron kang ketone wherein ito yung R1 mo, ito yung R2 mo, and gumamit ka ng isang reducing agent. That reducing agent may transform this aldehyde into a methylene group. By methylene group, we will have here our R2 and we have here our R1. So, we just remove our oxygen. So, dalawa yung pwede natin gamitin dito na reducing agent. Pwede tayong gumamit ng clemensin. So, ilan dun sa mga uh, Pwede natin gamitin dyan ay yung Clemensen reduction. Sa Clemensen reduction, ang ginagamit niya ay yung ating zinc with mercury yata. Zinc and mercury and concentrated, shortcut ko na lang ha, concentrated uh, hydrochloric acid. And pwede rin naman natin din gamitin ay yung Wolff-Kishner. Spelling ko ng FF yata yan. So, that will be ulit. Wolff-Kishner. Wolff-Kishner reduction naman, ang ginagamit naman dito sa Wolff-Kishner reduction para ma-reduce mo sa methylene group yung iyong aldehyde and ketone ay yung ating ito, diammonium nga bang tawag dito. Then, presence ng potassium hydroxide. So, pwede rin dyan gumamit ng tinatawag na K-test butoxide. So, ayan, search nyo na lang. So, this characteristic reaction, ang na next natin ay yung ating nucleophilic addition. So, bakit siya characteristic reaction? Dahil ito ay dun sa presence ng ating mga carbonyl groups. Ano? So, dahil dun sa presence ng ating carbonyl group, merong actually pwedeng mangyari tinatawag nating nucleophilic attack sa ating carbonyl group mismo. So, ano yung reaction na pwedeng mangyari or yung mechanism na pwedeng mangyari dito? So, in the presence of our nucleophile, what may happen is the nucleophilic attack will happen here in our carbonyl carbon atom. So, why is that? As you may have remembered, this is partially positive, yung ating carbon, dun sa ating carbonyl group. And we have here a partially negative side. So, what may happen here ay magkakaroon tayo ng cleavage ng ating double bond here na pwedeng maging site ng ating bonding with the nucleophile. So, bali ang flow ng ano natin, ng electrons natin is dahil papasok yung nucleophile papunta ron sa ating carbon atom, we will have here a move of electrons toward the oxygen. So that's why we have here a negatively charged oxygen in the first step of our reaction. And with the presence of uh, an acid, what may happen here is that acid will attack that oxygen, therefore producing our uh, this product wherein we have here a nucleophilic addition product. Okay? So, actually, may limang types. Apat pala. May apat na types ng nucleophilic addition na involve ang ating mga carbonyl group. So, we have here addition of cyanic acid o hydrocyanic acid. So, pwede rin ang ating addition of Grignard reagent. So, pwede rin namang yung addition of alcohol, and also we also have addition of derivatives of ammonia. So, for the addition of the addition of our hydrocyanic acid, ganito bali yung nangyayari. Bigay ko na lang yung general na ano. Pero this both works for our aldehydes and ketones. So if we have here our HCN, valid dyan class, dalawa yung ating parts ng HCN, or in yung CN yung ating nucleophile at yung H ay yung ating uh, electrophile. So what will happen there is, ang unang mangyayari yung CN, it will attach itself to the carbon. So we will have here uh, this product. Tapos, dahil negative na yung ating oxygen, dyan mag-a-attach yung ating hydrogen. So, we have here yung ating product or yung ating addition product. Wherein, we call this product our cyanohydrin. Bakit siya tinawag na cyanohydrin? Kasi kung mapapansin nyo, we have here cyano, by cyano, andyan yung ating carbon and nitrogen. And we have here our hydrin. That's why it's cyanohydrin. So sabi ko kanina, it both work for aldehyde and ketone. So hindi ko na bibigyan parehas. So how about addition of what we call Grignard reagent? So by Grignard reagent, ang Grignard reagent actually ay ano lang siya. Meron tayong R group na attached sa ating sa magnesium at sa isang halogen. So, paano ba pine-prepare yung Grignard na yan? So, pwede kang gumamit ng ating alkyl halide. Mag-a-add ka ng magnesium dun sa ating alkyl halide and you will be using dry ether dun sa reaction mo para mag-occur yung reaction, therefore forming our Grignard reagent. So, what happens to Grignard reagent? So, bale, tatlo yung nangyayari dito sa Grignard. Actually, ang Grignard class ay preparation ng alcohol. So, by Grignard reagent, halimbawa, kung meron kang formaldehyde, by formaldehyde, you have here your carbonyl, then you have here your hydrogen. So, if you use Grignard reagent on this formaldehyde, what will happen is you will have an nucleophilic attack towards your carbon. Wherein, ano ba yung magiging nucleophile dito? Ang nucleophile natin ay yung ating R group. So, wherein we will have here this form and we will have here this Grignard reagent here, yung MgX natin, and we will have here our hydrogen. And if you expose this product to acids, what will happen here is you will have this compound wherein magkakaroon ka ng OH imbes na MgX. And you have here your R group. You have here this hydrogen. Therefore, magkakaroon ka ng tinatawag nating primary alcohol. So, ganun din yung pwedeng mangyari dun sa mga higher aldehydes. But for higher aldehydes, ang mangyayari, since yung higher aldehydes mo ay meron kang R group dun sa may side ng ating carbonyl atom, if you expose this to Grignard reagent and also you then expose it to our acid, what will happen is you will have here your secondary alcohol. And dito yung R group mo. Meron ka pang isa pang R group dito sa baba. Yung R group na to ay yun yung galing dito sa ating Grignard's reagent. And you will have here this hydrogen. Okay. So, paano naman kapag ketones? Dahil merong tayong dalawang R group dun sa side ng ketone, if we expose this to, ito muna, lagyan natin ng number ha, kasi two-step yung reaction natin. We have here this Grignard reagent and then you will be exposing this to acid. What will happen here is you will form an alcohol wherein andito yung isang R group natin. Gawin natin itong star. Nandito yung ating galing sa Grignard's reagent and andito yung ating R prime. So, kapag methanol or yung tinatawag nating formaldehyde, we will have a primary alcohol. If we have uh, our higher aldehyde, pwede tayong magkaroon ng in-expose natin sa Grignard reagent and acid, we will have here a secondary alcohol. So, and for this one, we will have here a tertiary alcohol. Okay? So that is how you synthesize alcohol from ketones and acetone. Ketones and aldehyde. So, kung gusto nyo magkaroon ng different types ng alcohol, pwede nyo gamitin ito. Halimbawa, gusto mo lang gumawa ng primary alcohol, by primary alcohol, halimbawa gusto mong gumawa ng ethanol. And by ethanol, ang gagawin mo lang, magpe-prepare ka lang ng Grignard's reagent na wherein yung R group mo ay methyl lang. So, tapos gagamit ka ng formaldehyde para magkaroon ka ng ating ethyl alcohol. So, pakita ko lang yun kung paano nangyayari yun. So, sabi ko sa kanina, gusto mong magkaroon ng ethyl alcohol. So, what you can do is use dito yung ating formaldehyde. Then yung ating dalawang hydrogen. Gumamit ka na ngayon ng Grignard's reagent na methyl lang. We have here CH3MgX and yung first step ng reaction. And yung second step ng reaction will be addition of acid. And as you can see here, dahil mabe-break to, yung CH3 mag-a-attach dito sa baba. So we have your C. Andito yung CH3. Andito yung mga hydrogens mo. And you have here your OH. You can see here, this is actually an ethyl alcohol. Because you have 1, 2, then OH, then you have there your ethyl alcohol. So nakadepende dun sa structure ng gusto mong product na alcohol. Yung kailangan mong gamitin na aldehyde, ketone, and syempre yung consideration mo dun sa Grignard's reagent. May Grignard's reagent kung ano yung idadagdag mo na R group dun sa iyong MgX. Okay? So, as you can see there, kung babalikan mo itong ginawa natin sa ethyl, kailangan mo lang gumawa ng methyl halide. Kung ano mong methyl halide yan. Methyl chloride ba yan? Methyl iodide or kung ano man. Then you will be just adding your magnesium metal. After adding your magnesium metal to the methyl halide that is exposed to dry ether. By dry ether, wala itong kasamang iba. Ether lang. You will have your Grignard's reagent. Okay? So that is the addition of Grignard's reagent. Next natin is addition of alcohol. So, sa addition of alcohol, ayun, pwedeng two-step yung reaction na mangyayari. Actually, pabalik-balik yung reaction na mangyayari sa aldehydes and ketones when we actually add this alcohol. So, paano paulit-ulit na yung nangyayaring sinasabi ko? So, say we have here your aldehyde bearing your carbonyl group. If you expose this to alcohol, what will happen here is that you will form your this compound. Wherein you will have your OH there, you will have our OR here, and we have here our R group and our hydrogen. As you can see here, this is what we call our hemi-acetal. Like hemi-acetal, we have there our OR and our OH. That makes it an acetal. And if you add another batch or another mole of your alcohol, you will have this compound. And we have here our OR and another OR here sa baba. We have here our R group and our hydrogen. So, this is our acetal. Okay? So, ano yung sinasabi kong pabalik? Kung pwede natin gawin, ay pwede kayong gumamit ng dry acid. So, by dry acid, yung acetal mo, kapag na-expose siya sa dry acid, pwede siya maging hemi-acetal. And yung hemi-acetal mo, kapag na-expose mo siya sa dry acid, you will have your aldehyde. So, halos ganyan din yung pangyayari sa ating ketone. Ang kaibahan lang, you have here your ketone, R group there, R groups there. Pag ganun din yung itsura ng reaction, we have here our alcohol, our dry acid there. So, kung makikita nyo, reversible yung reaction na nangyayari. So, we'll have here our hemi-ketal. This is our hemi-ketal. Bakit siya ketal? Kung makikita nyo, ketone, ketal. Then we have here if we have another batch of our reagents here. What will happen is we will have here a ketal. For in our ketal is we have here our ORs, and we have here our R groups. Makikita nyo, halos parehas yan ang pangyayari. And it also follows our nucleophilic addition. Okay? And last but not the least, the nucleophilic addition is the addition of derivatives of ammonia. So by addition of derivatives of ammonia, if you have your aldehyde or ketone, you will be adding derivatives of ammonia. By derivatives of ammonia, you have there your NH2. Then we have there a certain group na attached dun sa ating ammonia. Kung ano mang groups yan. Mapa, uh, mapa-acid man yan, nucleophile man yan, or kung ano man. Yan yung so, paano to naging nucleophilic attack? So, ganito mangyayari. When it comes to aldehyde, dito ang ating carboxyl group. We have here our R group and our hydrogen there. If we add any derivatives of ammonia towards this dun sa ating sa ating aldehyde. Mangyayari actually ay total na cleaving ng ating oxygen. So bakit? Gawa ng presence ng ating hydrogen at gawa ng presence ng ating ammonia. So what will happen here is we will have this product wherein nandiyan pa rin yung R group, nandiyan pa rin yung hydrogen. Ang kaibahan lang, we will be having here our hydrogen and the group that is attached to that hydrogen. So from aldehyde, it will be actually converted into an imine. So, kahit anong addition of derivatives of ammonia will result into imine. So, that is similar for our ketones, wherein you have your first R group here and your second R group here. If you add your derivatives of ammonia, what will happen here is we will have here this imine. And we have this R group and this second R group. And last but not the least is our aldol condensation. So ito yung medyo nakakalito na part ng ng reactions ng ating ketones and aldehydes. But it deals more on higher higher aldehydes and higher ketones. So by aldol condensation, kung makikita nyo, that is actually from the word ald, pala, which is actually aldehyde, and ol, which means alcohol. So in some cases that we have this structure of our carbonyl atom wherein we will have this hydrogen, this carbonyl group bearing our double bond and another group here. Dahil dun sa sa presence ng ating tinatawag na alpha hydrogen. By alpha hydrogen, since bali ito yung ating magiging alpha hydrogen, kasi siya yung nakakabit dun sa ating alpha carbon. So what will happen here is this hydrogen is acidic enough to be abstracted by bases. So by abstracted by bases, if we add any base dito sa reaction na to, or dun sa substrate na yan, what happen is we will be having our enolate anion. And our enolate anion has this structure, which is actually have a resonance structure with this structure. We have carbon to carbon double bond. We have oxygen that is negatively charged, and also our hydrogen. So, ganyan yung nangyayari sa ating mga aldehydes kapag meron tayong bases. So, saan napunta yung bases? Yan. Kasama dyan yung hydrogen. So, uh, dahil dun sa anong yun, sa scenario na yun, na yung alpha hydrogens natin ay acidic enough para matanggal gawa ng bases, pwede tayo magkaroon ng tinatawag natin ganito. O yung mga tinatawag nating enolate ion. So, ano ang meron dyan sa ating enolate and ion? So, if you have your enolate ion and you added that enolate ion into other aldehydes or ketones, ano bang pwede mangyari? So, what may happen here is, for example, I have here another aldehyde. Say we have here RCl. Kung ano man yung attachment niya na nasa baba. Ano? And we added that our enolate ion. So, gamitin lang natin yung some structure wherein yung carbon yung ating negative charge. Ano bang mangyayari dito? Siyempre, yung usual na nangyayari, pwede tayo dahil dun sa presence ng negative charge nitong enolate ion natin, it can actually affect this carbonyl compound. Just like how our nucleophilic attack happens. So, pwede mangyayari, itong ating negative charge na to, it will attach itself to this carbon dahil dun sa tinatawag natin nucleophilic attack ng ating mga aldehydes. So what will happen here is magkakaroon tayo ng ganitong structure wherein yung ating isang aldehyde nandito, we will have here a negative charge about the carbon atom or the oxygen atom of our other aldehyde, wherein we will have here the attachment of that alpha carbon. Okay? We will have here the R group. Itong R group na to. Okay? Then, we will have here our hydrogen. Then, andito yung ating carbonyl compound. And as you can see here, ito yung side, itong nasa black, ito yung galing dun sa ating other carbonyl compound. And itong side na ito, sa kabila, ito naman yung ating enolate and ion. Okay? So, anong mangyayari pa dito? Anong pwedeng mangyari? Anong next na pwedeng mangyari dito? So, dahil dito, ang pwedeng mangyari ay kapag nag-add tayo ng ating base, say we have here our pH, yung, yung side ng ating, ng ating other carbon, ay magkakaroon ng additional hydrogen. So, tanggalin mo na natin. Kakaroon siya ng additional hydrogen galing dun sa base natin. Okay? Then, we will have here uh, yung galing naman dun sa inulate ion natin. Therefore, nagkaroon na tayo ng alcohol dito. And, syempre, may iwan na yung base dyan. Okay. So, kung makikita nyo dito, class, meron tayong dalawang parts ng organic compound ito. Andito yung ating alcohol at andito yung ating aldehyde or yung ating ketone or yung carbonyl group. So, yan na class, yung tinatawag nating aldol. And ald kasi aldehyde, ol kasi alcohol. So, what may also happen here is, ayun, pag nag-decay yung aldol natin, what happens is, ano ba, yung aldol natin, sulat ko na siya ng buo as isang compound. So, ito pa rin yung aldol natin ha. Okay? So, what happens to that aldol ay pwede siyang maging unsaturated. Kasi kung isipin nyo, ang dami masyado kasing functional group na present dun sa aldol natin. So, what happens here is we will have this compound wherein we will have an alpha beta uh, unsaturation. By unsaturation, hindi na saturated yung ating compound wherein we will have here this beta part and this alpha part, and we call this the alpha beta unsaturated compound. Okay? And syempre, saan napunta yung mga OH? Tsaka yung hydrogen? Syempre, magiging water na. So, magko-condense na siya. Nagigets na ba yung ibig kong sabihin? Mula rin sa enolate ion natin na naging present gawa nung base natin, nagkaroon tayo ng enolate ions. And once yung enolate ions ay na-expose sa ibang aldehyde, what will happen here is we will have an aldol kapag nagdagdag tayo ng base ulit. And due to that aldol condensation, naging aldol na siya. And pag nagtuloy yung reaction, pwede tayong magkaroon ng tinatawag nating alpha beta unsaturated compound. That is our aldol condensation. So basically, class, tapos na tayo sa ating ketones at sa ating aldehydes or yung tinatawag nating carbonyl compounds. So we already talked about their general structure, kung paano sila papangalanan, yung tinatawag nating nomenclature, their physical properties, and their reactions. So, in that, I will be ending this video here. So, have a good day. Bye bye.